Welcome to the fourth part of our video series. In this video, I'm going to show you how to use the commands that Convector and Hurley brings to your toolbox. As well, I'm going to show you what happens behind the scenes so that you can take and leverage these files that are self-generated for you so that you can get into more advanced scenarios. So in our previous videos, we learned how to create models and create controllers from a basic standpoint. These are classes that you can pretty much manage and mold to your business specifications. But now we're going to take a look into what commands you can use to first compile the code, this TypeScript code, into JavaScript code that can run in your Hyperledger Fabric network. As well, I'm going to show you how to create your development environment so that you don't have to get into all these YAML files that you typically have to understand in order to just set up your first network or do some basic things like creating users. Any project created with the Convector CLI brings some default tasks that you can use to leverage all these tools that I'm talking about. So if you go to the package.json, you can see in here that we have some default tasks that are usually, this covers pretty much all the scenarios that you have. For example, the install command, what it is going to do is to make all the installation of dependencies in your project. On the other side, we have this env restart, that this is going to call the local version of Hurley into this project, and it's going to run this command, hurl new, which is bringing your new blockchain network. On the other side, we have env clean, which is going to destroy the local installation of a blockchain network. This is pretty common. Since you are developing, you may end up creating some misconfigurations in your environment, or you may end up just creating a lot of examples and things like that you just want to erase. So these two tasks are basic for you to create your smart contract and also to create your development environment. So for example, if you want to just run this, you can do npm run and you select which command you want to execute. In this case, I want to execute env restart, which is equivalent that I just copy this hurl new and I run it in my command in my terminal. After a few seconds, you are going to get this set of results from the commands that were executed for you. So this is something important. If you run hurl new with the default settings, so I don't add any extra parameter, for you, there's going to be created a folder which is called Hyperledger Fabric Network inside of your home path. In this case, in my computer, it is users/Walter/Hyperledger Fabric Network. So if you go to that folder, as you can see, I have this one open already. In here, I have all the files that were generated for me. So this is important. Hurley is never going to create an extra abstraction layer. What it does is just make things easier for you. But behind the scenes, everything that is needed for a fabric network happens. So for example, if you want to see, let's say you want to understand the topology of your just created network, you can take the Docker Compose file and you can open this with your text editor and you can see everything that was created for you. The name of the container, all the parameters that Fabric needs, some things like some volumes that are mounted for you, for example, configurations, and so on. So if you want to take a closer look, you can do. Also, we can go into this folder again and we can check inside of this things like the Fabric binaries, which are the files that are used to compile some things. But also, if you check the empty folders, the hidden folders inside of this network, in here you can see these HFC folders. These are the specific folders containing the cryptographic materials per each organization. What does this mean? This means that for you, for every single user and for every single organization that you told the tool to create, here are going to be the private keys and the public keys. So this helps you emulate and and use these files inside of your code. So for example, if you want to install a chain code, you can use the configurations of the admin user, or if you want to just make an invocation, you can use the user one. By default, Hurley understands this topology of files and of the network. So when you do something like installing a chain code, it already knows which user it has to use, so you don't have to worry about this. But again, it is important that you understand all these files and that these files are there for you so that you can use them on your business case. So for example, if I erase all of this, and I come in here and I execute again the command. In this case, I can do this directly instead of running the npm task that I have in here. So I can do something like hurl new. But in this case, I want to create more organizations. So I want to tell this, let's create 4 organizations. And I want, in this case, 5 users per each organization. As soon as I execute this command, the folder is going to be recreated for me. If I erase something like a binary, it's going to be downloaded again. And I can again go and check all these files based on the configuration that I just specified to Hurley. So let's run this. Sorry, here's a typo. There you go. So there you go, everything was installed for us. There's a small summary of what was done. In this case, it created 4 organizations, as I told it. It also created these all users, including one admin user for doing administrative tasks like installing the chain codes, and also created 5 users that I can use to emulate and to simulate a real-life project. In this case, it also created 1 channel by default, but I could specify in here if I want more channels. For example, I can do something like channels. Let's create 10 channels, and it's going to do it for me. So let's go back to the folder and check what was created in here. So as you can see, I have these 4 organizations that I told the framework to use. Again, these are hidden folders, so you have to show them in your file explorer. But in here, you can see all the cryptographic materials, including the private and public keys of these users, as well these files that they include the configuration. It's a JSON that includes like the routing to your user, so you can load these through the Fabric SDK, through Convector, or directly from the Fabric tools, and you can start using those users. If we continue to explore these folders, we can see other things. For example, we have network profiles. The network profiles are the files that tell the Fabric SDK what is the topology of your network. So what it pretty much says is there are these nodes, I have these certificate authorities, they are in these addresses, they use these ports, so that the SDK knows how to communicate with the rest of the blockchain network. In this case, we have found that it is fairly common that when you create your application or your server, you end up mounting that into a Docker. So when you are calling your network from your computer, so this host, for example, in which I am working right now, and you make a call to a Docker container using the Fabric network, you communicate that differently than when you take a container, you take your code and you containerize your code and include it into the same network, then you use different addresses. So in these kind of scenarios, we also self-generate these inside Docker network profiles that you can use. So if you're running in your host, you use this file, but if you are running inside a Docker container, you can use this one, so you can be sure that you are actually able to communicate with the rest of your network. Now I'm going to show you how to install a chain code using Hurley. In this case, just like the installation and the removal of the network, here are some tasks for you that you can easily use. For example, I have this one called start. What it does is it do 2 things. The first one is this calls another task called package, and then this calls another task called install. So why is this happening like this? The first one, the CC package, what it does is it takes your source code in TypeScript and it is going to compile your code into a folder. This output folder in here that is generated through the Chaincode Manager tool, which is an internal Convector tool, is going to be the one that you take and you upload to the blockchain network. So this is the first task, the package. But after you package the code, you need to install this into your network. So what you do is you run this cc install, which is automatically run for you when you just run this cc start. And inside install, what it does is it goes to Hurley and it tells Hurley, here's the name of the chain code that I want to install. This is the language, the programming language that I'm using, and this is the path where the source code is. So as you can see, this is the same as when we were packaging. So the results of the package task is going to be used while installing your chain code. So we can run this pretty simply. Just remember the name of this smart contract. So you can do npm run cc start, and you have to pass a parameter. This parameter is just going to be the name of your smart contract. In this case, mine is called agreement. So I can just do this and click enter. So it is compiling my code right now. It is installing dependencies as well and defining some other Convector specific things. So as you can see, this folder was just generated for me. Inside of this folder, I have this packages folder in which it includes my code, which is already compiled inside of this dist folder. So I have the actual JavaScript code that is going to be run in my blockchain network. So as soon as this packaging is ready, now it is installing the code. So as you can see in my terminal, it says that it just installed in every single node in the network. In this case, I have 4, so it had to install in 4 different nodes from different organizations. And now the final task that it does for you automatically is instantiating the chain code. So it makes sure that your chain code is ready to be used. So there you go. Now we have our source code was uploaded through the install task and it was just instantiated. At any time, if you want to see what just happened for you, you can open your terminal and you can check the network. For example, if I do docker ps, I can see all the servers that were created for me. In this case, I have the basic network, but also I have the source code running in a specific container that is going to be called through a peer. The final task that I want to show you is how to upgrade your source code, because it is common that you have to make changes. So if I come in here, for example, and I decide that I need something different, for example, I may say, yeah, this finish date probably also needs a created date different than this one. For example, one that is based on, I don't know, something like geography or something like that. You can do any change that you want actually. So I can put in here random date just to make it a simple change. I can come in here and make the change. I save. So I can go to my tasks again and I can see that I have this upgrade task for me. So just like the other ones, what it is doing is making me easier to use Hurley in the default scenarios. So it says it's going to pass one parameter and a second parameter. The second one is the version. So I can come in here and I can run this like this, npm run cc upgrade. So I need to pass 2 parameters. The first one is the name of the chain code. So I installed this previously with the agreement name. And then I need the version. So I want to upload this in a version 1.1 and I click enter. Just like the installation task, it may take some minutes depending on the dependencies that you have and your internet connection, since we have some dependencies in our code. But there you go, now we have an upgraded version of our shadecode up and running. It is important to always notice that even though Convector and Hurley do things easier for you, they don't create extra tasks or extra layers that just abstract and don't let you access the native components like Fabric files, Docker Compose files, cryptographic materials, and so on. These are working with the native features, so in this way we make sure that even if there are new versions of Fabric, the difference between the Convector support versions and the new and latest versions of Hyperledger Fabric won't be really different from each other because again, for example, when we use Convector using in a Node.js backend, we can still access the SDK directly. And with Hurley, you can still access the files and you can change them. For example, if you don't like something, for example, in an upgrade script, you can just make things that work for you.